Hello everyone. Today let's solve the problem number 703, kth largest element in a string, right? So what the question states here. So we are given a stream of integers. See here, we are given a stream of integers, right? So we are given a stream of integers and a number k and a number k, right? So here we are given a stream of integers and the number k, right? So at any point we must return the kth largest number in the string. At any point we must return the kth largest number in the string. See here, kth largest, we have the kth, we have to return the kth largest, right? So here we have the methods kth largest and we have the method add. At any point, we must return the kth largest number in the string. As new elements are added here, just give me a second here. As new elements are added, this one add method. As new elements are added, the kth largest value must be updated in the real time. So as we add the this one new elements add as we add the new elements, so we have to update the kth largest value in the real time. So that's what they have said. So this sentence is very important. As new elements are added, the kth largest value must be updated in the real time. So we have to use add of val, this method itself, add of val, right? So we have to use add of val to insert a number and return the current kth largest and to return the current kth largest. So this is simple one, right? So we have to return the kth largest. And one more thing, we have to make use of the add of val, this one add method, whatever we are doing here, whatever they have given here, sorry, we have to use add of val to insert a number and return the current kth largest, right? So let's consider the same example, this one. Let's consider the same example, this one for the approach. So let me delete this one. I hope the question part is completely clear, man, right? So let's discuss the approach followed by the complexities and then let's write the code, right? So let's consider first example, this one itself. So here we have been given k equals 3. Initially this one kth largest, we have been given k equals 3, right? So add, for adding we have this one, 4 5 8 2, and for the second add we have 3, third add we have 5 4, this one again 10, 4 9, sorry, this one for first one, this one for second one, this one for third one, uh, this one for fourth one, and this one for fifth one. So did I get confused here? One second. Yeah, sorry. So this is for the kth largest, right? So 3 comma 4 5 8 2. This 3 k we have been given 3. This is for the kth largest numbers 4 5 8 2. For the add, so we have 5 add, 5 times add here, followed by the numbers 3 5 10 9 4. Right? So let's see the same thing here. So kth largest is nothing but the initialization part one. We know this one. So initialization part here, this one we have to go with the initialization. So here the return value is always null. The return value is always null. Just remember this one. The return value is always null for this one, right? So first thing is we will be going with the initial nums 4 5 8 2. We will be going with the initial numbers 4 5 2. So we have been given the initial number 4 5 8 2 and the k we have been given 3 within the kth largest, right? So this one, let's consider this one here. So we will be going with the initial nums 4 5 82. We will be going with the initial numbers 4582, right? For the first one. So this is fine. Let's insert one by one. Let's insert one by one into minimum heap. Let's insert one by one into minimum heap. Heap becomes 458. Heap becomes 458. Heap becomes 458 here, this one, right? So heap becomes 458 after popping 2, after popping 2. So here we had 4582. Now after popping 2, heap becomes 458 because heap size is greater than k. We have been given k equals 3 and heap, the last digit was 2, so we will remove the 2 from the heap. Now the value becomes 458. Now the value becomes 4 5 and 8, right? So now we will go with the 5 times add. First time add of 3 we have, right? So first time add of 3 we have, so this we will be returning 4. We will be returning 4, right? So first we cannot add this one, we cannot add this one. So here because we already have the three numbers, so we will return 4, we will return 4, right? So first what we will do for now, each add of 3 we are going, so this one of 3 we are going. So now we will return 4. First we will return 4, we will return 4. For the first one it will be null. So whatever we do here, we have inserted this one, we have removed this one, this is fine, but still the return value of the kth largest is null, as I have said. So this will be null. For the second one it is 4, it is 4. I hope these two are completely clear, man. Next, let's go with the third add here. Add of 5 we have. We will consider add of 5. So in the place of we have returned 4. In the place of 5, in the place of 4, we will be adding 5. We will be adding 5. This becomes 558 now. This becomes 558 now. Right? So this becomes 558 and we will return the first element nothing but 5. We will return the first element nothing but 5. Now we have this one null 4 and 5, null 4 and 5. Now let's move on with the next add of 10 we have, add of 10 we have. So here um, we have got null 4 and 5, right? So 558 we had. This one will be so we have this one value that we got here is 10, 10, right? So as we have the value 10 here, so we have to add the 10 at the end. We have to add the 10 at the end. We have 558, so 10 comes after 8, 10 comes after 8, right? So we have 5 uh, 8 and 10 comes after 8. So as we are making use of the heap here or the priority queue, so this one will be 5 8 10, 5 8 10. And what we will return the first element nothing but 5. We will return the first element nothing but 5 here. Null 4 5 5, null 4 5 5. So we are done with this part. Next we are left with two add operations on 9 and 4. Add of 9, add of 9. Here add of 9, add of 9 here, in this case add of 9. So how we will add this one? So we have 5 8 and 10, 5 8 and 10. Now we can just go with uh, we have to add this one, right? 9, right? So we can just go with 8 8. So this one 9 will be in the middle, or we can just go with the 8 10, 8 10 and 9, 8 10 and 9, as we need to add the 9, 8 10 and 9, and we will return 8. So this one we need to return, right? So this one we need to return basically 8. So now we have null 4 5 5 8, null 4 5 5 8. Finally we have add of 4, this one add of 4. So the previous heap, this one was a heap consisted of the elements 8 10 and 9, 8 10 and 9. So the final one we have to add the 4, we have to add the 4, but we already have the digits less this one greater than 4 here, right? So this will remain as it is, this will remain as it is, this will be 8 10 and 9 itself, 8 10 and 9 itself, and we will not be adding 4 here, we will not be adding 4 here. So in this case what we will do, we will return 8, we will return 8. So this will be null 4 5 5 8 8, null 4 5 5 double 5 double 8. So whatever the output that we got here, null 4 5 5 8 8 is equivalent to the output they have given for the example 1. So I'll just delete this one. See, null 4 5 5 8 8, right? Same thing they have tried to explain, same thing they have tried to explain here within the explanation part, right? So you can just go through this one, right? Same thing they have tried to explain here, right? So I hope the approach part is completely clear, man. I hope the approach part is completely clear. Next, as we are done with the approach, let's discuss the complexities part quickly. So what will be the time complexity here? The time complexity would be big O of logarithmic k. Big O of logarithmic k here, right? So the time complexity would be big O of logarithmic k for each add. method, for each add method, right? So for each add, nothing but for the insertion or polling, for the insertion or removal, right? Removal is nothing but the polling. I'm speaking of the poll property, insertion or polling in the heap of size k. So uh, it will be big of log k for each add operation. So for this one we are considering, this is the initialization part, right? So this one we don't have to consider. So let's consider the time complexity for this one. This is nothing but the overall time complexity would be big of logarithmic k, right? For add method basically, which involves inserting or the polling in heap of size k, right? So what would be the space complexity then? Space complexity would be big of k as well. So this would be time complexity, so this would be time complexity and this would be space complexity, right? So the overall space complexity would be big of k because heap stores only k elements. Heap stores only k elements. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of logarithmic k and big of k respectively, right? So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code, right? So the first part here would be, we will be going with the minimum heap to track the top k largest, right? So let's make use of the minimum priority queue. So we went with the minimum priority queue itself within the approach. Let's try to implement the same thing, or let's try to articulate the same thing that we had discussed in the approach in the form of code, right? So here let me give private, so this will be queue priority queue. So this one will be integer, so this one will be integer pq. This is fine. So the next step would be, we have to store the value of k, nothing but I would go with private int k, private int. Okay, so this is fine. So within the kth largest method, we have the parameters k and nums. So let's save k first. Let's save k, nothing but this dot k. Let me assign this one to the k. Also, we have to create the minimum heap, nothing but we are going with the priority queue here. So this one will be pq equals new priority queue. So I'll just copy the same thing. I just don't want to type priority queue. So this is fine, just the syntax. We have created the minimum heap successfully. After creating the minimum heap, we have to add the each number. We have to add the each number. For adding each number, let me go with the iteration part. Let's move on with the iteration part here. So we have to add the each number. We have to consider individual number of nums. So within the for loop, what we will do, we have to insert into the heap. We have to insert into the heap, nothing but pq pq dot offer, pq dot offer of num, pq dot offer of num. And finally we have to remove the smallest if size is greater than k. We have to remove the smallest if size is greater than k. Here in this case, let me write the simple if condition, pq dot size, pq dot size, if it is greater than k, if it is greater than k, this one will be pq dot poll. Means we have to remove the smallest if size is greater than k, pq dot poll, pq dot poll, right? So here uh, we are done with the kth largest method. We are done with the kth largest method, right? So now we have to write the code for add method. So add, within the add, we just have to add the new values to the heap, keep only the k largest elements, and then we have to top of minimum heap, nothing but it is the kth largest, right? So these three things we have to do. First, let's add the new value to the heap. I'll just make use of the offer operation here, right? pq dot offer, as we have to add the new value, right, to the heap. So I'll just make use of the offer, pq dot offer of val. So this is fine. Then we have to keep only k largest elements. Means here, if pq dot size, pq dot size here, if it is greater than k, if it is greater than k, then let's go with pq dot poll, pq dot poll, pq dot poll. So this is fine. Final step here would be, we have to go with, or we have to top of minimum heap, that is nothing but the kth largest, nothing but here in this case, let me return priority queue dot peak here, peak. So this is fine. I hope this part is completely fine, man. Let me format the code once. Let me format the code once and let me hit the run button. Let me hit the run button. So we have P has to be capital, man, priority queue, line number 3. So here, let me make this one P capital. Let me hit the run button again. We have again P has to be capital. Let me hit the run button again. So I had copied this one here as well, right? So now you can clearly see the sample test cases are getting passed. So this is easy problem, man. Easy, very easy to understand basically and to implement as well. So here the sample test cases are getting passed, means the code works absolutely correct for the sample test cases. Let me hit the submit button. Let's see whether this works for all the test cases or not. So here you can clearly see all the test cases are getting passed, means the code works absolutely correct for all the test cases. I hope the solution part is completely clear along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.